thanks very much for the invitation. It's always cool to talk about your work at groups like this. So yeah, don't hesitate to stop me if you have any questions or if anything is unclear or if you just want to make a point. Yeah, so I'm here to talk about Dynabench, which is a research platform for rethinking benchmarking in AI. It's a community effort with a whole group of people basically from all over the world working together on building this platform out. So I'm very happy to work with all of these people, and I'm just sort of the representative here. So it's not my platform, as Asher said, it's the community's platform. So if you haven't heard of Dynabench, you can go to dynabench.org, or I can tell you what it is. It's a research platform, a community-based scientific experiment, essentially, where we're trying to figure out if we can try to change the way we currently do benchmarking in AI, because we think that if we push the boundaries of AI research, we can make faster progress, and benchmarking really is an area where we need to improve things as a community. And as the name suggests, the idea here is to make as many of the things about benchmarking as dynamic as we possibly can. So moving beyond this sort of static paradigm of static test sets and static relationships between humans and models. So first, some news, if you know who I am or where Dynabench comes from. So I used to be at Meta AI, but I recently made the switch to Hugging Face. So with me, Dynabench is also getting contributed. This is currently in progress. I hope it's all going to work out. Dynabench is getting contributed to the ML Commons, which is a nonprofit organization with an interest in benchmarking and dataset creation and establishing best practices. So ML Commons has a lot of the big industry companies on the board, including startups and other places. So it's really a nice community ownership of the platform. So the inspiration for the platform comes from the observation that benchmarks, especially in NLP, have been saturating very rapidly. So as you can see here in this chart, so at the change of the millennium, when MNIST and Switchboard were introduced, things moved very slowly, and it took a good amount of time to saturate, meaning that this dark line here at 0 is human performance. So it took a while to achieve human performance. But the same was not true for NLP data sets when they came out. So we had things like Squad and Squad 2.0 and Glue and then Super Glue coming out, and they were saturated essentially within the year. So that's remarkable progress in NLP, but on the other hand, it's a bit deceiving because anybody in NLP will tell you that we are very far from having solved language. So what really is our goal and what is language? What are we trying to achieve here? So I've been accused of underhyping NLP's progress by some folks. So I do think there is some merit to some hype. So we're pretty decent actually, but not that great. I would say some IID problems when we have enough data and when we don't really care about the worst case. But I don't really believe that we are close to actually solving language. I think we're still very far away from truly general language understanding, which should be our aim, in the sense that we want to be able to encompass all of language's recursive and structured, generative, productive, and creative nature. So I still think we have a lot of work cut out for us. So that raises the question what we should be measuring. And I think what we're currently measuring is the average case and the head of the distribution, while what we really want to be good at is also the worst case and the tail of the distribution. So if you think about what language is, the sort of strong generalization that you get from language, you want to be able to learn language from some training corpus, and then you want to be able to generalize to something that is completely different potentially from what you have seen in your training data. So we don't really want to generalize to something that's IID necessarily, or at least ideally we wouldn't do that. We would be able to move beyond doing that and have strong generalization to even out of domain data, as long as we have language understanding. So the backdrop of the work that I'll be presenting here comes out of this this idea that we presented in Adversarial ANLI, this paper from 2019, where we talk about dynamic adversarial data collection. And that's really the starting point for this platform. So I'll talk you through this diagram so you get a sense of what we're doing. So if you're not familiar with natural language inference, in that task, you are given a context, so a paragraph, and you are given a hypothesis that is either true or false or neutral, so entailing or not entailing or neutral for that context. So what we do in this case is we have a human writer whom we give a context and target label, and they write a hypothesis, which we then give to a state-of-the-art ANLI model. We then take the model's prediction, we give feedback to the writer, so we tell them how they did, whether they fooled the model or not, because we can compare the model's prediction to the actual target label that the writer specified. So then we can check whether the model was wrong or whether the model was right. If the model was right, okay, that's sort of interesting. Still, we can use that data, we can put it in the training data. If the model was wrong, we obviously need to double check that the model was actually wrong and that we weren't just getting fooled by a mechanical Turk worker, for example. So if enough people agree, then this data is very useful because it's an example where the model currently fails. So this is something we want to learn from, and this is something we want to use to measure progress on. So what we do with these examples is we include them in the training data, in the dev and in the test set. And once we've collected enough of this data, what we do is we train a new model on the old data plus this newly collected data. And this model is now the new state of the art, which we can then put back in the loop for another round of data collection. So the idea is that you create this virtuous cycle of making models stronger and stronger with humans and models in the loop together. And so Dynabench took that idea and then built this comprehensive benchmarking platform around it, because there are many other well-known problems in benchmarking and model evaluation that we think we should be thinking about solving as a community. So saturation, which I just mentioned, is one of them, but there are also important things like bias and inadvertent annotator artifacts, where we want to make sure that our models don't just overfit on things that they shouldn't be overfitting on. And if you have this virtuous cycle where you keep putting models in the loop, then any bias that your model has will sort of be exposed and exploited by annotators. So you would fix biases over time. We would be obtaining more aligned models as a consequence of this process, because the alignment that you get from having a real human interact with your model is very different from the alignment that you get from a static test set. We want to encourage the community to move beyond the leaderboard culture. So we think everybody is way too focused on their ranking on a leaderboard with some trivial and arbitrary ranking functions. So we think we can make improvements there. We are allowing people to upload their models, which means that we can facilitate reproducibility, because the results that people self-report can very often not be trusted. So we think it's better if somebody else evaluate your model for you, so that other people can actually believe the results without having to verify it themselves. The models that would be uploaded would be accessible to anyone in the community. So we would be democratizing and making these models accessible to anyone who wants, including people who don't really know things about AI, who just are interested in it. The fact that we have model uploads also means that we have backward compatibility. So when a new data set comes out, we can evaluate old models on new data sets. And finally, we're also interested in thinking about utility functions, because it's pretty obvious, I think, when you think about it, that not everybody has the same utility function. So some people care more about efficiency, others care more about fairness. It depends on where you want to deploy a model, what your utility function is. And this is something we should incorporate in the way we think about benchmarking and model evaluation. So we should be moving beyond accuracy as a single metric towards a multi-metric future where people can specify their own utility function. So there's a couple of different roles on the Dynabench platform. We have task owners. So you could be the task owner of natural language inference. And for that task, you have a whole bunch of data sets. So this could be multi-ANLI and the Stanford ANLI data set and adversarial ANLI and metrics, so how you measure performance. And then we have model builders who train up these models, which are then submitted to an evaluation as a service cloud. And so what we do with the results there is we report them to the model user or the consumer, essentially, of these leaderboards, who can then make informed decisions about what models to deploy and what models to choose when. And then, of course, the sort of adversarial or human in the loop component comes from having these breakers. So these could be mechanical Turk workers or other crowd workers or linguistic experts or anyone you want. and they would be able to try to break your model, which gives you adversarial data, so failure cases essentially for your model, which you can then use to train up even better models, which you can use to inform your evaluation. So you can add evaluation data sets for that, or you can use them to inform the new data sets and metrics that you might be interested in. So this is a bit abstract, I concede that. So I think an easy thing for me to do is to actually just show you what this looks like for real when you go to dynabench.org. So I'll give you a bit of a demo. So this is dynabench.org. We have a bunch of different tasks on the platform. So things like ANLI and sentiment, hate speech, question answering. So if we go to sentiment, what you can see here is what we call a dynamic leaderboard. So these are models that were submitted by clicking on the submit models link here, which takes you to a GitHub repository where you can wrap your model to turn it into a Docker container that we can then evaluate. And so these models here, they're evaluated on different data sets, and what you can do as a consumer of this leaderboard is you can specify what you care about. So maybe you want to have a very fast, very space efficient model, and you really care about robustness. So as you can see, the ranking here changes depending on what your utility function is, so what your preferences are. And similarly, you could say, okay, maybe I don't actually care about this SSD3 data set, I just care about like the second round of Dynasent, which is this dynamic sentiment analysis data set we created. So this is the leaderboard. You can do other cool things like taking a snapshot or forking this leaderboard to have specific utility function settings. So on this task, one of the core things you can do is create examples that fool models. So here we have the create interface, as we call it, and you might just leave like a restaurant review saying something like, I was expecting haute cuisine, but I was served rather the opposite, something like this. So if you submit this to the model and then you get your feedback, and then so in this case we didn't fool the model because it said negative, and you can look at the model's predictions and you can keep going. Like I know that there's a couple of versions of this where it does fool it and a couple of versions where it doesn't fool it, which is interesting in itself, I think, just showing how not very robust these models currently are. So maybe this is a good point to maybe stop for questions if anybody has anything they want to ask. There is a question in the chat. Would the human interactive annotation strategy also bias the annotation? For example, the annotators may tend to come up with adversarial cases that do not align with the real world distribution. Yes, that would bias the annotation, but so it depends on whether you actually care about that. I can talk about that a little bit. In the rest of this talk, I'll revisit that question. So fairness and robustness, so what they represent in the leaderboard. So there's some explanation here when you hover over it, but basically what we do is we generate perturbations using heuristics. So for fairness, we change gendered words and names. So if you replace James with Jamal, then the model's prediction shouldn't change if the model's prediction is not dependent on James. So we think it's very important to have fairness and robustness as sort of first-class citizens in model evaluation and not just as an afterthought like it is in many places. What if you replace haute cuisine with horrible food? Yeah, I mean, try it for yourself. I don't know. I have a lot to talk about. So, but yeah, that definitely is interesting. So I encourage you to try it out for yourself on lots of different tasks also.
I have a question. So I played around a little bit with Dynabench earlier, and I think it's a really cool platform. And I was specifically playing with the hate speech task. Mm-hmm. So this specific task seems subjective, so that people can actually disagree and be correct about disagreeing on what the outcome is. Yeah. So how do you imagine handling that in the future? Because I think that's a very important aspect of subjectivity.
Yeah, that's super important. I agree. I mean, so hate speech, I mean, if it wasn't clear, right, these tasks are not owned by me as the sort of Dynabench representative. So every task has task owners And so those task owners come from academia, and they are the people who determine what the task looks like and how things are annotated and what the right label is. So these people, I don't know if you know them, but Bertie and Zirak and Hannah, they're like world-renowned experts in hate speech. So they actually do know what they're talking about. It's not some sort of arbitrary distinction, but you might disagree, and I think that's a very good point. But that's maybe a bit more of a meta point around what we're doing in NLP, where we're trying to discretize decisions that models make where maybe we shouldn't, right? So I think it's much better, speaking of subjectivity, to maybe model the distribution of toxicity and hate speech rather than actually just saying yes or no, this is hate speech. But yeah, so hate speech in particular is always very subjective. Does that answer your question?
Yeah, thank you.
Cool. Maybe I'll move on for a bit, and then I'll stop again for questions later. So yeah, there are a couple of very common objections and misconceptions that people have when I first tell them about the platform. So I thought it would be good to nip some of them in the bud before we kind of get misaligned on some of these things. So this doesn't necessarily have to be adversarial. It's just set up that way now because that's an easy way to measure whether the example people create is actually interesting. So if the model was fooled, it's interesting, but you can define interestingness in different ways. For example, through uncertainty, if you're interested in like active learning style, uncertainty sampling, or other sort of reward functions that you give people. So it doesn't have to be adversarial at all. It's also not just about model fooling examples, right? So as I said, we're still using the non-model fooling examples in the data sets as well. And so those are not just getting discarded and thrown away. They're still useful, but it's a different kind of data. So maybe we need to work on methodology for dealing with that. We're not only paying people for fooling. So all of these data sets collected through the platform, we pay people in any case, and we give them a bonus if they fool sometimes, not even always. It's not just restricted to NLP. So we also have a vision task for object recognition. We have a visual question answering task, which is multimodal vision and language. We're adding a speech task. So I think there's a lot of other modalities that we can add as we go along. Expensiveness, so it is a bit more expensive to collect data if you have to have people be very creative, which is one of the things that people need to do here. But at the same time, we have some research, which I'll talk about, that shows that you can get the cost to go down quite significantly. So it's probably not as much as an issue as you might think. This approach is unfair to specific models. So if you only have one particular model in the loop, that model is getting unfairly punished. I don't really care about being fair to a particular model. I want us to deploy the best possible model in the world. So if I have to be unfair to Roberta for that, then I will happily accept that. So in the longer term, there are very easy fixes for that problem where you might have an ensemble in the loop rather than having one particular model. So we already showed that you can have ensembles in the loop and get better results in a couple of papers. So you could have a very diverse ensemble, or you could have, let's say, the top 10 models on the leaderboard in the loop at any given point in time, so that you're not unfair to any particular model in particular. There is some risk of cycles and the fact that you might, and so somebody already asked a question about this, where you might sort of shift too much and not have natural data anymore. I think we found that really depends on the task. So some tasks that are sort of almost solved, like extractive question answering, in that case, you get less natural data, but it sort of depends on the task that you're interested in. And we have some results that I also talk about here that show that this is really not as much of a problem as you might think. And finally, underhyping, I already addressed that a little bit, but yeah, I definitely think underhyping is a lot better than overhyping. So I'm happy to underhype a little bit and maybe tone down some of the expectations that people might have about the capabilities of NLP models for deploying them in real world settings, because I think it's very dangerous if we don't think about what we're doing. So the broader research program here is to look at what happens when we put humans and models in loops. So can we make faster progress this way and get better measurements? Can we, in the process, hopefully collect data that has fewer biases and artifacts so that we get more robust and better aligned models? Can we figure out what we're still missing? And can we democratize model evaluation in a way where we can make all of this reproducible and accessible to the community at large. So we have been writing a bunch of papers coming out of the team. So this is just a recent overview of papers coming out of the project. So there's a couple of, so this one here is sort of the overview paper, and then we have some data set papers. So this is a hate speech data set. This is a sentiment analysis, another hate speech data set focused on emojis. Here's one on visual question answering. So these are all created using this process. Then we have a bunch of evaluation papers where we look at things like, can we do evaluation as a service in a holistic multimetric way? So the Flores task at WMT was evaluated using Dynabench. So that's large scale multilingual machine translation models. And then finally, we have a bunch of method papers that try to dive deeper into this particular method of dynamic adversarial data collection and trying to understand better what we do and what we don't want to do in this process. So in this talk, I'll mostly talk about the method papers that you see here, and I'll start with the first batch of 3 here, and then I'll talk about the last one after. So this work, so most of this work that I'm about to talk about is by Max Bartolo et al. And so the idea here is to have humans and models in loops. So as I've shown you, you can have humans and models in loops where you have sort of a discriminative model like an ANLI model or a hate speech model, and you have a human trying to generate examples that fool this model. But obviously you can do the same with a generative model, perhaps trained on the data coming out of this human, to try to fool another discriminative model. So this is sort of like your standard generative adversarial setup. But what you could also do is have the model trained on human data help other humans fool models, right? So now you have sort of a generator in the loop trying to fool this model together with this human. And so where we're going, as you can see here, the sort of trend line downwards is where we have lots of models and lots of humans working together in loops with lots of models and humans. So I think this really is the way that we can make progress as a field, where we obtain training data this way from these interactions. We get much better aligned models, and hopefully we can make faster progress and better measurements along the way. So that's sort of where this research direction is headed. So in this first paper, we show that you can improve QA models, their robustness specifically, by doing this synthetic adversarial data generation. So generating with a model to make another model more robust. So the way that works is as follows. We first find a bunch of passages that are interesting in Wikipedia. Then in those passages, we do answer candidate selection. Then for those answers, we generate questions. Then we do a bunch of filtering and relabeling things so that we can take the interesting question answer pairs and then train up new QA models, which are even better. And then you could, in theory, repeat this process to get better and better data. So what we have found when doing this is when you have synthetic adversarial data derived from human adversarial data sets, so things like adversarial QA, then this really improves accuracy and robustness quite substantially. So doing this synthetic data augmentation leads to better accuracy. It also leads to better accuracy on different data sets. So what you see here is MRQA, so out of domain generalization with the SynQA works a lot better than if you just train on the regular data. And so what's interesting here, I think, and this is a nice way to evaluate whether your model is actually more robust, is the mean validated model error rate. That's what this stands for, also actually goes down. So this means that if I take this model and I put it on Dynabench and I try to have people fool this model, then their fooling rate, so their success rate when fooling the model, goes down quite substantially. So that means that those models are more robust and harder to fool. And so then the next logical step in this direction, of course, is to take that model and give it to a human. So that's what we do in this paper, models in the loop, aiding crowd workers with generative annotation assistance. So this model here is essentially an annotation assistant given to this crowd worker whose job is to fool this model. And the underlying questions here that we're interested in are, can we take these generators in the loop and then solve some of the main issues that you might have with adversarial data collection. And so the main issues that you would see, as I mentioned, are that it might be more expensive because you want people to be creative, and being creative takes time. It takes a lot more time than just very quickly writing some example of entailment. And time costs money, so you have to pay for that, right? And the same with collecting adversarial data. The other issue is that it could be noisy because people are incentivized to be much closer to the decision boundary, which means that sometimes they might also be wrong, or they might be a bit tricky, or they might be a bit adversarial to the annotation process. So you have to make sure that the examples you collect are actually higher quality. And so by having a generative adversarial assistant, perhaps people can also be less noisy and provide higher quality data. So that's what we're looking at in this paper. And just to give you a concrete example of the sort of loop, what this looks like, if you have a paragraph like this here, which is about golf, I think, then the annotator would say something like, okay, my answer is going to be 2. Then the generative adversarial assistant generates a question, how many strokes are needed to make par, and then the annotator sort of re-annotates that example. So they change a couple of words maybe, or if this example is already good, they can just try to copy it directly and see what happens. And then, so this example is given to a state-of-the-art QA model, which gets it wrong and predicts 3 rather than 2. So that's concretely what the setup looks like here. And so what we do in this study is we revisit a question that was already asked by one of your colleagues at CMU. So Divyansh, when he came to intern with us, did a very nice paper on the efficacy of adversarial data collection for question answering. And what we found in that paper is that across a variety of QA models and data sets, we find that models trained on adversarial data usually perform better on adversarial data sets, but worse on a diverse collection of out-of-domain evaluation sets. So essentially, what we found here is that if you do this for 1 round, then standard data collection might be better for generalizing to out-of-domain evaluation sets than adversarial data collection. So we did a similar version of this experiment in this paper with Max, and we actually found sort of the opposite of that finding. So I think so this is still preliminary because we want to verify this and collect a lot more data for this, but we found that, yeah, sort of the opposite happened for us. So preliminary takeaway perhaps is that you have to be very careful with your setup and be very careful with the instructions and onboarding and things like that when you deal with Mechanical Turk workers. And if you are very careful with that, then things might be okay after all, because what we find is that if you don't have a model in the loop, then you are a bit faster. So it takes fewer time per example, but the examples that you do get out are actually much better, so much more interesting in a sense, because they have a much higher model error rate, and the training on this data also gets you much higher performance, not only on the adversarial QA data sets, but also on squad and on MRQA. So this is a nice finding, I think. And so obviously you could try to improve even further on this, the sort of top line here, by trying to use the generator in the loop in a standard data collection setup. So essentially you're not telling people to full models, you're just saying, okay, here's a nice example, do you want to do anything with it? So if you do this, and so you can do a couple of different sampling strategies. So just looking at the likelihood or adversarial as a sort of post hoc sampling strategy, or you could sample by uncertainty, then you get interesting examples. And so the time that people take goes down, and again, the model error rate, so the interestingness and the accuracy on these other data sets goes up. So that's nice for standard data collection, but then obviously I'm sort of expecting adversarial data collection to do even better. And so what we showed after this is that when you use a generator in the loop, you can make adversarial data collection essentially as fast as standard data collection. So the concern about this taking more time and needing to pay more money basically goes away. And the nice trade-off is that you actually also get higher quality data with better domain generalization. So it's sort of a win-win-win. So I think that's a very exciting result because that basically shows that adversarial data collection can be useful, even though initially it was mostly meant as an evaluation paradigm, not really as a training paradigm per se. And so we try to improve on this even further by doing something called answer prompting. So if you recall the passage I showed you about golf, one of the high cognitive barriers for people is that they have to figure out what the answer is that they want to ask a question for. So if you prompt with an answer that is going to be probably interesting, which you can do in a variety of ways with a variety of sampling strategies, then you don't have to force annotators to pick the answer, which means that they get even faster and they get even higher quality. So just to summarize sort of all of the numbers in all of the tables that I just showed you, the starting point for traditional data collection is about 50 seconds per example with a validated model error rate of 0.6. And in the end, when you do this sort of adversarial data collection with a generative adversarial assistant and answer prompting, you get a validated model error rate of 6.08, and it actually is faster than traditional data collection. So you can improve on both fronts, right? The quality and the time that it takes, which I think is very exciting. So there was this paper, which you might have seen coming out of AI2, where they introduced a new paradigm, which I thought was a bit laughable. I tweeted that I wish Einstein had done this because it would have been a lot easier if he had just said that he had invented a new paradigm for Brownian motion. But this paper is sort of claiming that new paradigm, even though it came out a bit later than the work we did. So sorry if that's a bit petty, but they essentially do a very similar thing to what we're doing. So they're over generating with GPT-3 and then they're filtering down with human review. So they have a generative model in the loop in order to, in this case, try to reproduce or upsample essentially ambiguous examples. So what we're doing is trying to find adversarial examples instead. So this models in loops idea seems to be interesting and seems to have legs. So yes, we can collect higher quality data than the static method. We can actually collect higher quality data than regular human and model in the loop when you have this generative process in the loop as well. And yes, we can actually collect data at a cost that is lower than the standard human in the loop approach, and actually matching or being faster than standard data collection. So I think that's a nice takeaway from this group of papers. So next I will talk, let me see how much time I have. Yeah, maybe so do people have questions about what I just talked about? If not, I can move on. All right, I'll move on. So yeah, next I'll talk about this work by Eric Wallace, who interned with us last year over the summer on analyzing dynamic adversarial training data in the limit, where we sort of take some of the findings that I just talked about and try to apply them in the limit and see what happens, to see if we get cycles, for example, or weird stuff. So the starting point, again, just to remind you, is dynamic adversarial data collection. So we're collecting data against a model, we're turning that into training and dev and test sets, then we're training up new models that are stronger and we're putting them back in the loop, right? So we're doing dynamic adversarial data collection over lots of different rounds. And the experimental setup in this case is that our starting point is the same starting point as the one we had for adversarial ANLI, which is this all ANLI data set. So multi-ANLI plus SNLI plus fever ANLI, if you know what that is. So that's just a very strong ANLI model. And then what we do is before we start doing any data collection whatsoever, we hand construct an expert curated test set covering a wide range of ANLI phenomena. So this is a test set essentially that tests how good are you really at ANLI, and it's supposed to be designed by ANLI experts like Adina and Eric and Robin as well, who generated examples that any self-respecting state-of-the-art ANLI model should get right. And so what we do is we do dynamic adversarial data collection then with this starting point model for 20 rounds. So adversarial ANLI only did 3, and in this paper we do 20, which sort of is in the limit. I guess you could keep going, but at some point we had to stop. In order to make this feasible and affordable somewhat, we select 10 contexts only. So we have 10 contexts that we're doing ANLI on. So the findings that I'll present here are limited to those 10 contexts, but I think it's reasonable to assume that the same would be true if you do this at scale. As I said, we have a broad range of phenomena, and it's really a wide coverage test set. So what we find is what looks to be a virtuous cycle, as I said at the beginning. So we have some really nice results, I think, where if you do this over 20 rounds of data collection on the validation set, so this is sort of a combination of the data coming out of these 3 different approaches, then you do a lot better with dynamic adversarial data collection, the green line here. So what we're comparing here is non-adversarial, which means no model in the loop, versus static adversarial, which is always the same model in the loop, so this the same starting point model, versus dynamic adversarial data collection, where you keep updating the model every round. So every one of these models is different and keeps getting better and better. So they keep getting harder and harder to fool is the idea. And so they yield more interesting data. And so that's what this plot here suggests. But obviously the really interesting case, and so we've talked about out of domain generalization and things like that, and whether dynamic adversarial data collection actually works better than standard data collection. And so on this held out test set that was pre-constructed before we did any data collection, we see that in the beginning it's sort of a mixed bag, but then after a while, so this is like several thousands of examples, then the dynamic adversarial data just gets a lot better and gets a lot higher test accuracy on this wide coverage test set. So we're still quite far away actually from human accuracy on this, but as you can see, this is really just a lot better than no model in the loop, standard, boring, old school data collection. So I think if you take the results from what I just talked about and combine it with this finding, then I'm sort of wondering why, as a field, we are not just only doing dynamic adversarial data collection with models in the loop in the future. So if you are going to collect a new data set, put some models in the loop, and your data will probably be better and you'll get it a lot faster. So obviously there's an interesting underlying question here, which is where does the performance come from? Is it really the adversarial process, or is it something else? And I don't actually think it's necessarily the adversarial process. It's more just that by doing so, we're incentivizing annotators to generate very diverse examples. And so diversity is good, especially if you have a wide range of phenomena that you want to cover, right? So what we show here in this data analysis is that the dynamic model has a lot more diversity than the other models, that the complexity is much higher. So they're just more difficult and more interesting examples, and there are fewer artifacts in this adversarial data than in the static or than in the no model case. And what you can see here is that the green line, so the fooling rate essentially keeps going down. So the model gets robuster and robuster, it gets harder and harder to fool by the annotators. And the same is obviously not true for the static model, because that's always the same model that doesn't update. So that's sort of like randomly fluctuating. So the takeaways, as I already hinted at just now, I think adversarial data collection looks like a good alternative, especially if you do it in the dynamic way over multiple rounds for traditional crowd worker data collection. And this is a nice side benefit, considering the fact that the original goal for Dynabench was evaluation and just trying to understand how robust the models really are. But it turns out that the data that you get out of this process is also very valuable. And I still think there's a lot of room for interesting work in trying to understand that data better. There's a recent trend, I think, as I mentioned, the new paradigm paper already. So if you look at OpenAI's recent papers on incorporating human feedback, and Instruct GPT is another example of this, where they're also trying to do human and model in the loop. And I think if you do this over multiple rounds, we're going to see quite substantial progress in that field too. But they're using it in Instruct GPT for having better aligned models. And I think if you keep aligning, then this will definitely be a good and interesting direction. So there's a lot of further work needed on many very interesting questions. So I think there's still a question around the naturalness of adversarial data, and does that actually matter? So what we found in what I just talked about is that it maybe doesn't matter that much, but still it's something you want to protect against, and you want to maybe do smart things with your data to try to avoid it. So I think there's still a lot of work to be done there. There's interesting questions around dynamic adversarial data collection and how it relates to active learning and continual learning. I think we can try to do interesting things there, including maybe sort of core machine learning solutions for problems where we know what the model in the loop actually was. So you can do optimization over data set with the knowledge of what the model in the loop was, which I think is a promising direction as well. Because if you look at, I don't know, like spam detection or hate speech detection on Facebook, then that model collects data with models in the loop, right? So those examples are sort of informed by the performance of previous models. So I think that's just an interesting research direction. And then finally, we can explore things like ensembles in the loop, like I said, different scoring functions, etc. So there's a lot of cool stuff to do in this space. I think it's only just getting started, and there's a lot of interest in the community in data-centric AI. Was there a question in the chat? From Keith, there are quite a few technical steps needed to upload a new model to Dynabench. Do you think model uploading should be simplified? Yes, absolutely. Are there any higher priority platform improvements on the Dynabench roadmap? Yeah, so I mean, I would love to improve that. I think it's still way too complicated, and that's one of the reasons that we don't have a lot of models on the leaderboards. I mean, actually, it's a nice segue to this point here, where because I am now at Hugging Face, maybe we can try to make things a bit easier for people, because Hugging Face is very good at making things easier for people. But yeah, in general, I think it's a question of just not having enough manpower to try to really work on that. So if you're a student and you have some time and you're interested in helping out with this platform, then you're very welcome to join us and maybe help us improve this process, because it definitely is something that needs to be improved. So yeah, you can do so if you want, because everything on the platform is completely open source, MIT licensed. So the whole platform, you can just dig through the code and see for yourself what it's doing, and you're free to submit PRs or ask us for interesting things you might be able to add. We also open it up with this thing called Dynabench so essentially anyone can add their own data collection task without needing to do any coding. So you can just submit a configuration file in this Dynabench format, and then out comes a interface just like the one I just showed you, where people can submit models, where you specify the input output of the model. Then so you have your own dynamic leaderboards, you can do your own dynamic data collection with models in the loop from that leaderboard. You can add your own evaluation data sets and do your own evaluation as a service stuff. All of that without needing to do any single line of code if you are using like a standard classification task. So if you want to do something custom, then maybe you have to do some work, but it's easy to do that because it's all open source and the code is relatively clean, I think. So yeah, our goals really are to just keep growing the community and keep pushing the boundaries. And so I really think it's very important as a community that we start thinking about these points here. So this is from the CTO of Kaggle, Ben Hamner. So when we announced Dynabench, he said it's nice to see Facebook creatively improving number 4 here. So I agree with him that if you look at the progress that we're making in the field, is very much focused on the compute and the algorithms, right? So everybody wants to do like model work and like be the cool kid with the new latest giant pre-trained model and things like that. But I think it's actually much more interesting to work on the data side and the measurement side and trying to make progress there. So I think that's a general tendency that a bunch of us in the field are moving towards. So also to that end, and this is actually what I just said, everybody wants to do the model work, not the data work. So there's these data cascades in high stakes AI that are just, that's something that we have to keep thinking about. So Dynabench is teaming up with ML Commons. So this is a nonprofit that is really focused on trying to establish best practices. And we're also doing something called data perf as a part of ML Commons. If you've maybe heard of ML perf, which is about benchmarking hardware for machine learning, data perf is sort of the data-centric version of that coming out of ML Commons, and data perf is going to be hosted on Dynabench. Yeah, last but not least, just some acknowledgements to my fantastic collaborators. So all of this work, I mean, I'm just sort of the conduit, but all of the real work was done by all of these other people. So Max and Eric and Tristan especially, and Robin and Adina have been co-advising, and it's a giant team of people who've been involved with this platform by now. So yeah, thanks a lot to all of those people. So thank you very much for listening. Yeah, as I said, we would love your help. So if you want to join the open research community, we're completely open, then feel free to do so. I also wanted to let you know that there will be a dynamic adversarial data collection workshop at NACL. So you can go to the adcworkshop.github.io and check it out. We're actually going to have a shared task where people can submit models and people can try to fool models and things like that. So I think it's very exciting to try to continue building community around this new paradigm. So that's all I had. Thank you very much for listening.